Applications of linear systems. In this lesson, we will look at a few problems that can be modeled using linear equations, and then we can set up a system to solve for that particular problem. However, before we begin, let's take a look at why linear systems are useful. Consider a Toyota versus a Chevy. Mr. Mac and Miss Fanny are both taking a road trip to LA from San Jose. Mr. Mac in his red Toyota started 50 miles. Let me make a note, this is in miles. From San Jose and drives at an average speed of 30 miles per hour. Let's make a note of that so that we don't forget. So Toyota begins at 50 miles and travels at a speed of 30 miles per hour. Okay. Miss Fanny in her blue Chevy started 10 miles from San Jose and travels and drives at an average speed of 40 miles per hour. So the Chevy started at 10 miles from San Jose and travels at a speed of 50 miles per hour. Okay. The question here is, when will their car be next to each other on the freeway? And how can you tell? So to investigate this, what we can do is we can complete a distance chart, and we're going to see when the two distances are equal to each other. All right. So this is an example of a motion problem that we will discuss further later. First of all, we know that distance, right? Distance can be found by taking the speed times the time. So if you travel 30 miles an hour and you travel for 2 hours, multiply them together and you get a distance of 60 miles. So we're going to investigate and see the distance of these two cars, and if their distances are the same, then we know that they're side by side. Time is going to begin at the 0 hour, 1, 2, 3, 4, and 5. Okay. Remember, the Toyota had a 50-mile head start. So it began 50 miles from San Jose. Each hour that goes by, it's going to be able to travel 30 miles. So that brings it to 80. And then the next hour, that brings it to 110. And then third hour is going to be 140. And then the last or the fourth hour is going to be 170. And we probably can stop there. The Chevy began at 10 miles from San Jose. But for each hour that goes by, it's able to travel 50 miles, which means that at the end of the first hour, it is 60 miles from San Jose. And then another hour that goes by, it would now be 110 miles from San Jose. And I guess this is where we can stop, because if you look at the table, we notice that the two distances are now equal, which tells us that the two cars are now side by side on the freeway, right? So to answer the question, when will the car be next to each other on the freeway, we can say that the car will be next to each other on the freeway at the second hour. How can you tell? And there's a lot of ways we can tell, right? We can tell by looking at the table and looking at the distances. If the distances are the same, then they are side by side. We can also take this and we can also turn it into a graph as well. So let's call this the horizontal axis. Let's call that time in hour. And let's call the vertical axis our distance. So this is the distance. And this is going to be in miles. Okay. So we're going to make each one block like that as 1 hour. And each of these small blocks will be 10 miles. Okay. So then you have your 50-mile mark here. 100 mile mark there, and then 150. And we don't even have to go that high to find where they would eventually be side by side. So what we're gonna do is we're gonna take these red values and turn it into a line, because these are just numbers. These are just like order pairs. So for the Toyota, we can model its position. This is the position of the Toyota. So it began, this is the beginning, right? It began at 50 miles away. An hour later, it is 80 miles away. So an hour later, 50, 60, 70, 80. Okay. By connecting these two dots, we can basically finish the rest of the table. Okay. This gives us the position of the Toyota as time passes. So 2 hours later, the Toyota is now 110 miles away. Okay, because that is reference to 110 miles. We do the same thing to the Chevy. The Chevy began at 10 miles from San Jose. And then an hour later, it is 60 miles. So an hour later, it is there. Okay, an hour later, it's 60 miles. We graph these two. We construct a line connecting the two dots. And this allows us to have a system of equations. The solution to a system of equation is where the two lines intersect. So notice that the two lines will intersect at that point, and that point is our solution. Okay, the solution is 2, 110, which allows us to answer this question. The two cars will be side by side 2 hours later. The distance where they will be at is 110. See? So how can you tell? You can graph two equations and find the point of intersection, and that tells us where they will be side by side, or when they'll be side by side, and at what distance. All right? This is the reason why solving a system of equations is important. And by the way, we can use equations to model the distance of each car. For example, the Toyota can be modeled by y, stands for your distance, equals to the speed is 30, and then the time is unknown, so you let x equal to the time, and then your y-intercept is the starting position, so that's 50. For the Chevy, okay, y is the distance of the Chevy, the speed is 50, x is the time, which we don't know, and then the starting position is 10. Okay, we solved this by what did we do to solve? We found the intersection, right? But the intersection is where the two distances are equal. So what we could have done is we could have taken the distance for the Toyota. This is the distance for the Toyota, which is the letter y, and take that and plug it into this y. So we set them equal to each other when they were looking for same distance, and that allows us to find the time. Okay? All right. So I want to start at motion problems because we're kind of on this verge of motion problems and I don't want to switch gears. So let's go ahead and do another motion problem. A car leaves Costa Mesa and travels east at 56 miles an hour. At the same time, a truck leaves Costa Mesa and travels west at 48 miles an hour. How many hours will the two be 260 miles apart? So let's begin by constructing just a simple sketch to know what we're working with here. So one vehicle travels west, the other vehicle travels east. The one that's traveling west is the truck. So the truck is traveling west, and it's traveling west at 48 miles an hour. The car is traveling east at 56 miles an hour. And we want to know when the two vehicles will be 260 miles apart. So the truck is going to be here somewhere. The car is going to be here somewhere. We want to add the distances together, and then we want to see when they'll be 260 miles apart. That's the intuition that we're working with, okay? So here's what we're going to do. We're going to let x, we need to define variables. So define your variables. All right, so x, usually we use t as time, but for now I know that you guys are more comfortable with x. So we're just going to go let x equal to the time. Okay, and then the time is going to be in hours. And we're going to let y equal to the distance. Okay. To help us organize the information that we need, let's go ahead and construct a table. So draw a table. This table is going to contain 3 rows and 3 columns. Make it 4. 1, 2, 3, 4. Okay? You're going to name, in the first column, call that car and call the other one truck. Okay. These columns, the first column will be your speed. This is how fast you're traveling. The second column is your time. And the last is your distance. Okay? Now, we know that the car is moving at 56 miles per hour. We don't know we don't know the time, so we're going to call it x. We don't know the distance as well, so we're going to call it y, okay? The truck is moving at 48 miles an hour. The time is also unknown, and also the distance is also unknown, so we're going to leave those as x and y. So from organizing this information, then we know that the distance of the car can be found, by multiplying the speed and the time. So the car is 56x. The truck distance is 48 times x, because this is the distance, and distance is speed times time, so it's 48x. Now, the main point, and the point that you need to actually solve this problem, is to interpret this question. How many hours will they be 260 miles apart? So the clue is, if the two vehicles or any two moving objects starts at the same location and move opposite from each other, in the opposite direction from each other, when we find their total distance, they move apart. If we want to find their total distance, then we must add the two distances together. Okay, keep that in mind. When two objects started at the same position and moved apart in the opposite direction, if we want to find their total distance, we need to add the two distances together. So this is the scenario that we're going to work with. So we need to add the two distances together, okay? Because they're moving apart, moving in opposite direction. That's the clue. All right? So the distance for the car, distance for the car plus the distance for the truck, we need to add them together. And because they're 260 miles apart, we want them to equal to 260 miles. The distance of the car is represented by 56x. Truck's distance is 48x. And that should equal to 260. Add these two together. That gives us 104. So 104x equals to 260. And then we're going to go ahead and divide both sides by 104, which will give us 2.5. 2.5. And remember that x is time. So technically, the question is how many hours will they be 260 miles apart? We found it. It's 2 hours and 30 minutes. Okay, so we're done with this question. But let's write down our conclusion. The truck and car will be 260 miles apart in 2 hours and 30 minutes. Awesome. Let's move on to our last motion problem, and then we'll go back and we'll finish the only total value problem. But maybe before I begin, I want to point out that the table does help you organize your information a lot. And also keep in mind that apart means that you have to add the two distances together. Also, always start every problem by defining your variables. That's one of the most important things. And also to maybe draw a graph to help you visualize what you're working with. John starts jogging at 5 miles an hour. 1 hour later, Debbie starts jogging on the same route at 7 miles an hour. How long will it take Debbie to catch up to John? So a timeline is actually helpful for this problem so that you can visualize what's going on. One, two, three, 4. John starts jogging at 5 miles an hour. So here's John. Okay. Debbie, 1 hour later. So an hour later, Debbie starts jogging on the same route. So this would be Debbie right here. So Debbie, once Debbie started, if Debbie's 1 hour into her jogging, then John would have been 2 hours into his. Okay, and that's why I kind of backtrack 1 hour, as you can see. We define a variable, we define our variables, and then we construct a table to help us organize our information. So define the variables. Now to define the variables, we look at what's in question, right? So here is how long will it take for Debbie to catch up to John? Long refers to time, so let x equal to time. Okay. And because in a motion problem, distance is important, although distance is really not specific in this problem, but distance is another thing that we don't know, but it's part of this problem to answer the question of time. So let y equals to the distance as time passes. Let's construct a table. Okay, you need 3 rows and 4 columns. 1, 2, 3, and 4. Speed, time, and distance. Let's label John to be the person in the second row, and then Debbie will be the person in the third row. We do know their speed, so John jogs at 5 miles an hour. John's time, we don't know how many hours John jogged, so we're going to call it x. We also do not know his distance, so we're going to call it y. Debbie speed is 7, but here is an interesting thing, guys. Debbie jogs 1 hour less than John, so it should be x minus 1. Hopefully you agree with me on that aspect. And then her speed is also y. Okay, so using the table, we can now we can now set up an equation that represent John's distance and Debbie's distance. So distance is speed times time. So John is 5x. Debbie is y equals to 7 times x minus 1. All right. So how long will it take for Debbie to catch up to John? This question is very similar to the question that we started here. How long will it take for, I think I used this paper. How long will it take for the Toyota to, the Chevy to get up to the Toyota? So we want the two distances to be equal to each other, right? That's how we identified how long, okay? So in this case, we want to know how long will it take for Debbie to catch up to John. So we also want the two distances to equal to each other. So we want John's distance to equal to Debbie's distance. Okay, so in a catching up sort of problem, you want the two distances to equal to each other. What does that mean? It means that you need to take the distance for John and the distance for Debbie and then set them equal to each other. Okay, so here's what it's going to look like. It's going to be 5x equals to 7x minus 1. You distribute the 7, okay, and then you combine the terms. So I'm going to subtract 7x to both sides, and that leaves us with 2x minus 7. So x comes out to be 3.5. We have found the time where the two distances are going to equal to each other, which means that Debbie is going to catch up to John, and we can now answer the question. So Debbie will catch John 3 hours and 30 minutes later. Okay. Awesome. So remember, read the question carefully. Maybe sketch a graph of some kind, a timeline, two items moving apart. Define your variables. Make a table to organize your information. Usually it's going to be distance equals to speed times time. And then you want to either set them equal to each other if you're catching up. If you're moving apart, you want to add them together. Okay, so the situation will kind of depend on the problem. All right, we're going to go back and we're going to do our last problem, which is number 1. This is a type of problem called total value problem instead of motion problems. Okay, so H and K, which is kind of similar to H and M, sold 52 shirts, short sleeve, which is $8.25 each, long sleeve, $11.50 each. They sold a total of $464.75. How many of each kind were sold? So for total value problems, what I like to do is I like to circle the known information in red. So this is what I know. Okay. And then I also look at defining my variables first by reading the last sentence. So I begin the process by defining my variable. Okay, so define the variables, and the variables are what you don't know, right? So how many of each kind were sold? Well, there's short sleeve and there's long sleeve. I don't know how many of each kind were sold, so I'm going to go let x equals to the number of short sleeve shirts and y equals to the number of long sleeve shirts that were sold. Okay, now I set up write a system using the known information. So what do I know? I know 52 shirts were sold, meaning x plus y equals to 50. So x plus y equals to 52, because 52 shirts were sold. Using the other known information, 464.75. So the total purchase of the short sleeve and long sleeve adds up to 464.75. Each short sleeve is 825, so 825x plus 1150y, that equals to 464.75. Okay, I have a system of equations. I have three methods that I can use to solve. I will solve this system using the substitution method. So solve using substitution. I begin by solving for y in the first equation. So the first equation will now become negative x plus 52, because I subtracted x to both sides. And then I'm going to make a substitution of that into the second equation. So the y in the second equation is that. And I'm going to use a calculator to help me with this problem because it involves decimals that will save us time if we use a calculator. So 11.5 times 52 brings it to 598. So 825x minus 11.50 plus 598 equals to 464.75. Combining these, that gives us negative 3.25x. And then we're going to subtract 598 to both sides. So 598 minus 464.75. That gives us negative 133.25. And then if we divide that by 3.25, that brings us to 41. So divide that by negative 3.25, that brings us to 41, which tells us that 41 short sleeve shirts were sold. Okay? Now we gotta find the number of long sleeve shirts. So take this and plug that in there, and that gives us the number of long sleeve shirts. So y equals to negative 41 plus 52, and that comes out to be 9. So from the H&K store, they sold 52 shirts. We knew that 41 of them are short sleeve and 9 of them are long sleeve.